In this video, I'd like to solve a couple of logarithmic equations using some of our properties and laws of logarithms. For the first equation, I can combine the two logarithms on the left side by writing the product of the input values. Log of x plus log of x minus 1 is the same as log of x times x minus 1. Now I can use the one-to-one property of logarithms and say that because these two logarithms are equal to each other, the inputs must be equal to each other. So we end up with the equation x times x minus 1 equals 4x. Let's solve this quadratic equation for x. If I subtract 4x from both sides, I get x squared minus 5x equals 0. Solving this by factoring, we get two possible solutions. Either x equals 0 or x minus 5 equals 0, which indicates that x equals 5. I'd like you to consider these two solutions and compare them to the input values of the original equation. If I plug in x equals 0 to the original equation, I would have log of 0 plus log of negative 1. Both of those are undefined. Log of 0 is not a real number. Log of negative 1 is not a real number. I can only find the logarithm of a positive number. So this is considered an extraneous solution. It is a solution that we arrived at using algebra, but it does not fit in the context of the original problem. And I'm not going to consider it as a final solution. There's no such problem with the solution x equals 5. If I plug in the x equals 5 to the original equation, I have log of 5 plus log of 4 equals log of 20. All of those logarithms are defined. So our only solution here is x equals 5. In some examples, I may be able to simply apply the definition of a logarithm, writing it in exponential form, to solve for x. In the following example, let's consider the outside logarithm first. If we have log 2 of all of this inside material is equal to 1, that is the same as saying 2 to the power of 1 equals log 4 of x. Well, that looks a little simpler than what we started with. So let's try to evaluate that. We have 2 equals log 4 of x. And once again, I'll think about the exponential form of this equality. If I have log 4 of x equals 2, then we are saying that 4 to the power of 2 equals x. Therefore, x must be equal to 16. Here's our solution to the original equation.